to Statistics, Unit 1, Lesson 4, How many pairs of shoes do you own? Today we're going to be learning about how to make a STEM plot and using the acronyms CUS and BS. So the first thing we did today is that everyone recorded the responses of how many pairs of shoes they own. We actually did it with the TI Inspire Navigator, sent it to the information, and we sent it back. So the first thing we want to see is that remember that this is quantitative data. The data is recorded as a number, and it's not a category. So it doesn't go into a category. So this is the data that we recorded, and it is a STEM plot. And the way I did the STEM plot is that you can see 0, 1, 2, 3, 4, 5. That is my STEM, which represents the tens. So for instance, 3 and then a line 2 is 32 pairs of shoes. So for all of these, for instance, here we go. The 5 here represents 5 pairs of shoes. The next 5 pairs of shoes, 7 pairs of shoes, 8 pairs of shoes, and so forth and so on. For the next one, the 1 is here, so that's 10. So 1, 0 is 10, 1, 0 is 10, 1, 0 is 10, 1, 2 is 12, then another 2 is 12, 13, 15, etc., etc. So if there's no data, like right here, that means nobody has shoes between 40 and 49 pairs. You cannot make this on your Inspire calculator, but you can order the data. So I am going to show you that. All right, so let's go to just some data. And I think I have showed you this before, but I'm just going to show you again. So for instance, let's just grab some other data that's not ordered. Like this here. Well, this here is ordered, but I'm just going to show you how to order it anyway. All right, so for instance, you're going to go ahead and in order to do this, the first thing you're going to do is from your home screen, from the data when you turn it on, you're going to push New Document, List and Spreadsheet. You're going to enter your data. You're going to make sure you're going to put some sort of a title. I'm just going to title it Title. And I'm just going to make up some data. All right, I just made up some data just so I could show you how to sort it. So then you're going to go all the way up, keep going up until it actually highlights, push Menu, Actions, Sort, and it automatically is already there, hit OK, and then you notice it sorts the data. So that's nice and handy for me so that when I do a STEM plot, I have how many are in each STEM. Okay, so let's go ahead and read this data. It says, what % of the class have 10 or more pairs of shoes? So 10 or more pairs of shoes, this here is 10. So if I count all those, that's 1, 2, 3, 4, 5, 6. I'm going to count them all, boom, 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 and aha, get 18. There are 25 pieces of data, and 18 divided by 25 is 0.72 about, and which is 72%. Describe the shape of the data. So for the describe the shape of the data, you are actually going to take the data and you are going to take your paper, if you could right now, and rotate it rotate it 90 degrees left. Turn it one time left. And that allows you to see what the shape of the data is. So I'm going to show you here if you have and you're able to draw on the data, you can see that you can it actually looks like little histograms is what it looks like. So you can see that it's skewed to the right. Are there any outliers? Well, we haven't learned a lesson yet as far as the mathematical rule to check it. However, we do look at 50 and it looks like it's kind of way out there. So it's probably an outlier. Okay. This is splitting the STEM. If I split the STEM, I would be making the data, just because if the data is too clumpy and I can't really read it, I would take the 0, instead of the first 0, the 0 being from 0 to 9, the first 0 would be from 0 to 4, and the next 0 would be from all my 5 to 9s, the 1 would be from 10 to 14, and this would be from 15 to 19. but it's still skewed to the right. It's just a little bit more clear. The data just makes it look a little bit easier to read. If you want to put data in to the calculator to here, you can click this app you can type in this app and do one quantitative variable, single group, and make a stem plot. You can also click to make a histogram so you can see the difference. Okay, so the main thing is here's the steps of making a stem plot. First of all, the leaf is the last number and the stem is the first number. So for 14, the leaf would be the 4 and the stem for 14, 1 would be the stem and it would represent 10. Don't skip stems even if they have no leaves. That just means that there's blank. Like for instance, right here, there was no 40. We didn't skip it. We just put a 4 with no data. And always include a key. If you split a stem, that's data from 0 to 4 and 5 to 9 instead of data from 0 to 9. You can also split it twice where it's 0 and 1. 1 is a stem, and then 1 and 2, 2 and 3, and so forth and so on, where it's just 2. If I'm describing and comparing data, remember we're using our acronym CUS, which is C is the center, which is our number 2. U is our unusual features, which is outliers and gaps, which is number 4. CUS is the shape, which is number 1. It shows skewed left, skewed right, or symmetric. And the other S is the spread, or my variability, how spread out my data is. So if I were to do this one here, and you can see this here, if I lay a blanket over it, draw it, and then remember it's a stem and leaf, so we're gonna turn it on its side so that we can see what's shaped. And it looks like it's got a tail, or the outliers are a little bit to the left, to the smaller numbers towards 76. So you can see that this one is a little bit skewed to the left. But what we're gonna do here is we split the stems because if I didn't split the stems, if you notice, and I split the stems, look at them, there's 1, 2, 3, 4, 5. So there's 5 split stems because the data was just too clumpy and it wasn't very easy to read. This one here I have is called a split stem and leaf, or excuse me, a back-to-back split stem and leaf. It's back-to-back because you can see on the right-hand side has secondary enforcement and the left-hand side has primary enforcement. The stems for both of them are the 7, 7, 8, 8, 8, 8, 8, 9, 9, 9, 9. The reason I don't have any other 7 that starts here at 75 and 76 is because there's no other data to, all the other 70s, 75 and below, there's nothing. So I don't have that there at all. So it shows the back-to-back. The reason I have a back-to-back, then it's really easy to see which data has more data in one area versus another. So that's kind of why I have a back-to-back stem plot and stem and leaf plot. But be careful because on the secondary enforcement, if you turn it on its side, 90 degrees left like I told you to do, you can see what the shape of the data is because the 76 is the smaller number, all the way to the 92 is the higher number. Now if you could take your paper, please, and turn it to the right where primary enforcement is up. But the problem is if you notice, the larger numbers are on the right and the bigger numbers on the left, so it's actually backwards. So it's going to appear that it's skewed to the right, but it's also skewed to the lower numbers. It's skewed towards 78, 76, all these lower numbers. So this is also skewed to the left, but because it's back to back, it's actually mirror imaged flipped. So you have to be careful with that. So that's why I like sometimes to call it skewed to the lower numbers, because if you talk about that it's skewed to the lower numbers, then you'll think, okay, on a graph, the lower numbers are always on a number line, are always to the left, like 0, negative number, everything to the left, the bigger number is always to the right. All right, and here is just comparing the data. When you compare the data, you need to use numbers like higher, bigger, smaller, and then you're also going to have to use specific data, or specific data. So go ahead and you can read these and do your check for understanding, and I hope you guys solve this well. If you have any questions, let me know. See you next time.